All right, hello everyone. This is actually my the second time today I go live on Facebook. It's not very easy to do Facebook live from China because we have to use VPNs, and VPNs are not often not very reliable. So what happened is that the VPN went down halfway through my Facebook live. So let's do it again. Okay, that's a good way to teach us how to be patient. All right. So yesterday we talked about resources, factors of production, decisions, opportunity cost, and usually something that comes right after that is the idea of a production possibility curve, how much an economy can produce with the resources at its disposal. And there are two main ways we can represent this production possibility curve. We can represent it as a straight line, which indicates constant opportunity cost, or we can represent it as a concave curve, we sometimes say bowed out, which indicates increasing opportunity cost. And in this live today, I would like to give you some ideas on how you can introduce this concept of increasing opportunity cost and how you can use examples to explain students why it is often more realistic than the idea of constant opportunity cost. Okay, let's do that, and I will check the Facebook page and the VPN on a regular basis just to make sure that uh, it's okay, that the VPN is still on. All right, so there are two ways you can explain it. The first thing you can tell is that it often becomes more and more difficult to produce each additional unit of output, meaning that you need to allocate more and more resources of an equal quality to the production of each additional unit. And therefore, as you divert more and more resources towards the production of one good, you have to sacrifice more and more of other goods. And therefore, the opportunity cost is increasing. I'll use two examples to show you why this might be the case. The second way you can explain that is to say that resources have different characteristics. They have different qualities. Some of them are very suitable for the production of one particular good, but not very suitable for the production of another. So the idea is that as you start producing one good, you will start by using the resources or the best suitable for that particular production process. But then if you want to produce more and more output, you will need to start using and to involve resources that are not very suitable for this particular production process. And again, I will use another example to illustrate this situation. Okay, so the bottom line is that it doesn't matter why we have to use more resources, but in both cases, we will need to use more resources to produce each additional unit of output, and therefore the opportunity cost is going to be increasing. All right, so let's use examples. The first one that I use is something that is very common in economics. We use Robinson Crusoe, his story. This guy on a desert island, castaway on a desert island, and the only resource that he has is his own labor, time, of course, and his own labor. And he can use his own labor to produce two goods, fish and coconuts. To simplify, let's just assume that it only takes the same amount of time to catch each additional fish, 20 minutes, 20 minutes of his own labor. However, the production of coconuts, it's a bit different because you see that on this island, you only have two coconut trees. You have a small coconut tree and you have a big coconut tree. And you also see that some coconuts have already fallen down on the ground. And let's just assume that all coconuts have the same qualities, okay? So the output is homogeneous, same quality. And this is our friend Robinson. So let's assume that initially he has not collected any coconut yet. So all coconuts we see on this picture, they are available. So if you are smart, you should start by collecting the coconuts on the ground, simply because it's easier. Easier means that you will not need to allocate many resources to collect. these coconuts. Collect means to pick them up and to open them. So we have 6 coconuts on the ground. So when I start collecting coconuts, it only takes 5 minutes of my labor to collect and open each coconut. And 5 minutes of my own labor is 1/4 of the time that I need to catch each fish. So for that reason, the opportunity cost of collecting the first, second, third, up to the 6th coconut is only 1/4 of a fish. A low opportunity cost. But then if I want to collect more coconuts, all the coconuts on the ground, they are gone. So if I want more coconuts, I have no choice, I have to climb. But I should start by climbing the small tree, simply because it's easier. There are only 3 coconuts on the small tree. But it's more difficult, right? To climb the small tree and to pick up these coconuts than to pick up coconuts on the ground. So that's why now it takes 10 minutes of labor to collect each of the 3 coconuts that we have on the small tree. And 10 minutes of my labor represent half the time that I need to catch one fish. So for that reason, the opportunity cost of the coconut number 7, 8, and 9 is equal to the value of half a fish. So you see, the opportunity cost has increased from 1/4 of a fish to half a fish, simply because it's more and more complicated to produce each additional coconut, and I need to allocate more resources to the production of coconuts. And finally, once I have picked up all the coconuts on the ground and all the coconuts on the small tree, if I want to collect even more coconuts, the only coconuts left are the ones on the big tree. And obviously, climbing the big tree is more difficult. So it will take more of my time. Let's say it takes 20 minutes of my time to pick up each coconut on the big tree. 20 minutes is exactly the time that I need to catch one fish. So in this case, the opportunity cost of the coconuts 10, 11, and 12 is exactly equal to the value of one fish. So this very simple example, I think, is very effective to illustrate this concept of increasing opportunity cost when it becomes increasingly difficult to produce each additional unit of output. The second example that I use is about oil wells. And the idea, the bottom line, is that when we start producing oil, we want to extract oil where it's easy. So what does it mean to extract oil where it's easy? It means that it's often onshore, and we should extract oil where the deposits are not very deep. So you see that the first oil wells were not very deep at all, 240 feet deep. The average Texas oil well is not very deep itself. And then if we want to produce more and more oil, we might have to dig deeper and deeper, or we might have to start building some oil rigs and to start drilling from these offshore rigs. And as you can imagine, uh, it's increasingly difficult. It becomes more and more difficult because we have to dig deeper. So this raises some technical issues. Same thing like building an oil rig adds many constraints that makes it more difficult to extract oil. So I think this picture is quite interesting to illustrate this concept of increasing opportunity cost. You see that we start digging deeper and deeper. This one is like the deepest oil well. And look at that, temperature at this point is well over 400 degrees Fahrenheit. So it shows you that this adds some technical problems that have to be solved. And the bottom line is that the more difficult it is to extract oil, the more resources we will have to allocate to extract each barrel of oil, and therefore the opportunity cost of extracting oil will be increasing. You probably know this one, Deepwater Horizon was famous for the accident. This was an oil rig that exploded. I forgot about the year. but you see we started digging deeper and deeper. So well, I think you see you understand the message, and yeah, I think it's really useful to illustrate increasing opportunity cost. Okay, and the last example that I want to use, let me just check that my VPN, yes, it seems to be working. That's good. The last example that I want to use is to illustrate a situation where resources have different characteristics and are not equally suited for the production of different goods. So here there are two goods that we can produce. We can use rice and potatoes. And all right, I'm not an expert at like farming, but I think that I'm pretty sure that you need to have soil of different characteristics. The characteristics of the soil have to be different if you want to grow rice and if you want to grow potatoes. So in this example, I basically assume that we need a field that is more, or a climate that is more humid if we want to grow rice well, and a climate that is more dry if we want to grow potatoes better. All right, this is perhaps not exactly how it works, but let's just make this assumption together and you'll see that it's going to be easy to understand. Okay, so we have three fields: field A, field B, field C. They have the same area, 4 square meters each, but they have different characteristics. So field A is in a very dry area. Field B is in an area that is neither too dry, neither too wet, and field C is in an area that is very wet, very humid. So, and here in the middle, you have the productivity of each field in terms of rice and potatoes. So it tells you the amount, the size of the area that you need in each field to produce each bushel of rice and potatoes. So you see that field A is not very good at producing rice. You would need the entire field to produce just one bushel of rice. Field B is better at producing rice. You only need 2 square meters of the field, so half the field to produce one bushel. And and field C is very good at producing rice because you only need 1/4 of your field to produce each bushel of rice. And for potatoes, it's the opposite. Okay, field C is not good at producing potatoes. You would need the entire field just to produce one bushel. Field B is just so-so. You would need half the field to produce one bushel of potatoes. And field A is pretty good at producing potatoes, as you only need 1/4 of your field to produce each additional bushel. Okay, so now let's say that we want to produce rice. All right, so if we want to produce rice, so we start from 0 bushels of rice. Well, what would be the smart thing to do is to start growing rice in the field that is the best suited for this production, which is field C. So if we start growing rice on field C, if we grow rice in the entire in the entire area of field C, since it only takes 1 square meter per bushel of rice, it's clear that we can grow 4 bushels of rice in field C. Okay, but of course we have to give up something. If we use this field C, to grow rice, we have to give up potatoes. So how many bushels of potatoes do we give up for each additional bushel of rice? Well, each additional bushel of rice takes 1 square meter of this field, and with 1 square meter of this field, you can only produce 1/4 bushels of potatoes, okay? Because it takes 4 square meters for 1 bushel of potato. So with 1 square meter, you can only produce 1/4 bushels of potato. So that's why when you produce the first, second, third, and fourth bushel of rice in field C, the opportunity cost of every bushel of rice that you produce is equal to 1/4 bushel of potatoes. Okay. Now, what if we want to produce even more rice? So field C is already used. Okay, so we cannot grow more rice on field C. What we should do is to use the next best field, the one that is the best suitable to produce rice, which is field B. Okay, in field B, every bushel of rice that you want to produce takes 2 square meters of this field. So you can only produce 2 extra bushels of rice in this field. Okay, so the fifth and the sixth bushel of rice that you produce in field B. Right, what is the opportunity cost of each of these additional bushels of rice? Well, you see that in field B, it takes the same area to produce each additional bushel of rice or potatoes, which means that every time you use, let's say, half the field to produce 1 extra bushel of rice, you give up 1 bushel of potatoes. So you see that as we increase the production of rice, the opportunity cost of each additional bushel of rice increases from 1/4 bushel of potatoes when we used field C to 1 bushel of potatoes when we use field B. Okay, and finally, what if we want to increase the production of rice even more? Well, field B and C have already been used, so the only option that we have left is to use field A. So how many extra bushels of rice can we produce in field A, which is really not very good at producing rice? Only 1, because you see that it takes 4 square meters per bushel, which is exactly the size of field A. So we can produce a 7th bushel of rice in field A. And how many bushels of potatoes do we give up? We give up 4 bushels of potato. Since it only takes 1 square meter per bushel, we use 4 square meters, so we give up 4 bushels of potatoes. So you see that I think this is a very clear example to illustrate that as we increase the production of one good, we have to start using resources that are not suited for the production of this good, and therefore the opportunity cost is going to become increasingly larger, bigger and bigger. Right? Hopefully the VPN is still working. It seems like it's working. Perfect. So I'll stop here for today, and tomorrow I'll try to talk about something else that is related to production possibilities. Why not perhaps economic growth? All right. Thank you, everyone. Have a good day and talk to you soon. Bye bye.